Do I need what?
To your port.
Oh, I thought you need a massage or something.
Oh, yes.
Relax me a little bit, huh? All right, so what do we...
There's your USBs right in the front.
There we are. Everybody's here. Good morning or good afternoon or... Number one, I never like anybody sitting back there, so come over. Come inside. No place to hide. Come over, fill the gap. You're going to get a lot of participation. Come on, guys. Get friendly. No space among friends.
I didn't expect you to be that close.
I'm not going to be that close. Don't worry about it. So you want me up here?
Yeah.
So let me just... I got to get my glasses. All right, there we are. Come on, move. I'm seeing you. Come on, move. Doesn't matter. Closer, yes.
If you go too close, then you'll only get about here. So you can see what's being recorded on.
Okay. So I got to get my my PowerPoint. Which one is this? This is... All right. Where is intro? Okay. There you are. All right. So, I'm Kiyoshi Digipur. Some of you might have seen me on convocation. I'm the dean. I'm also a mechanical engineer by training. By research, I'm in the bioengineering right now, but you know, that's the nice thing about engineering. So, what are we trying to do this introduction to engineering? Now, some of you might wonder, what am I doing here? And the whole idea is that this is really building a good foundation for you. And I'm going to explain what it is about. But then also who we have in this course to assist you. We are all part of the same team. You know, we're not here just simply to learn on your end and for me to teach at this end. It's a learning and teaching at the same time, goes both ways. We're going to be learning from your learning, and obviously we're going to use that to improve our, you know, our course, and hopefully it gets better and better every day. So, actual course is called Introduction or Introductory Mathematics for Engineering Applications. And the reason for that is that, first of all, what are the textbooks? This is the required textbook. I think we have electronic version if you have not bought it already. This is the book. It must be in the bookstore right now. And also there is a suggested book on MATLAB. And I'm going to explain what MATLAB is. But then we also have a number of people that are going to assist you. Now, part of, I guess, how many of you have received emails from me? Okay, not all of you. I'm kind of surprised because all of you must have received an email from me. In this morning, I actually sent another email to those of you who have really not gone into Blackboard. Blackboard is our means of communication. You need to make sure that you access it quite regularly because that's the only way I'm going to be communicating with you. My name is Kiyoshi Digipur, as I said. It's very hard to pronounce for you right now, but I believe, you know, I promise you at the end of this course you're going to be pronouncing it very well. What we are also doing, we're doing a team teaching. Dr. Lee, stand up. Dr. Lee Bai is a professor of electrical engineering. He's going to be in charge of teaching you MATLAB. Then we have Dr. Helferdy. the handsome man sitting there.
My wife sends him a check every month.
Electrical engineering. John is going to be helping me in this course. Our emails are there. It is in the blackboard. You don't need to really write it down if you don't have to. Alex Pilapakam there, professor of mechanical engineering back there. He's also, his office is on the 6th floor. I will also send you his home number later on. You don't mind, right? Robert Ryan is not here. I guess he's still vacationing somewhere, right? But he's a professor of civil engineering. And he also will be participating. Of course, we have our graduate teaching assistants. Where are you? Stand up. And Peter is going to be available in the labs, in the recitations to help you out. So what is the course objective? The objective is basically to increase the student retention. Why is it important to retain you here? The fact of the matter, of course, is engineering is a difficult discipline. And the most important part of becoming an engineer is what you have already done. You have decided to come to this college to be trained as an engineer and to become an engineer. So why can't we keep you here? Many of you are not really sure what engineering is all about, right? Raise your hand if you really do not know what you're going to go through during our curriculum. Okay? Yeah. Be honest. That's a fact. And then you wonder, they keep talking about math and engineering. What has engineering got to do with math? And that the whole idea of this course is to show you why math is important, but also don't be scared of it. Because once you understand why we insist on you learning the math, and then see its value on the topics that you're going to go through later on, then you realize how valuable it is. So it's important to spend that little time on those topics and therefore make sure that you have a good feel of it. Now, of course, we obviously like to keep all of you here. But once you leave this class, you have a better understanding of the relationship. And by understanding that relationship, we are pretty confident that you're going to stick with us. We have put a lot of resources. Just imagine that you have 4 or 5 very experienced professors working with you. You also have a graduate teaching assistants working with you. In our labs, we are going to have undergraduate teaching assistants working with you. In our recitations, we are going to have undergraduate and graduate teaching assistants. All of these resources are at your disposal, and you need to really take full advantage of it before you leave my course and our course, and then hopefully we get to keep 100% of you, and at the end of this year we're going to celebrate it together and look back and say, oh my God, this was so easy and this was so wonderful. All right, any questions so far? Have we introduced this little guy here? No? Okay, so this little guy here is recording me, and we're going to make sure that pretty soon you're going to be turning around and looking at you. We are recording all of our sessions, and the sessions are going to be available on Blackboard. So later on, if you forgot or you found it very difficult to understand me, first of all, how many people can understand me? Come on, don't be shy. This funny guy with a funny name, funny face, funny accent, So be vocal. And I'm not talking about this course. We're here to serve you, including myself, from the top to the bottom. We're here to serve you. If you do not vocalize, if you do not share your opinion with us, we don't know where you stand as far as your education experiences. All right? So, we have many ways of communicating your your suggestions, your concerns. Sean Fagan, who's sitting back there. Sean is the director of our undergraduate studies. Sean is in charge of advising and also provides you some assistance as far as tutoring and so forth. So if you need any assistance, Sean is the person. I also send you his home address too. All right. So those of you who visited us before, you learn that the programs we have is an accredited program. Do you know what an accredited program means? Come on, what does an accredited program mean? Right, engineering is a professional degree. Like medicine, like law, we get certification, we get certified. We also become professional engineers. Professional engineers who can actually sign off on engineering topics, on engineering projects, and then the government will stand behind you, like a medical doctor. And for that, you need to graduate from an accredited program. Does that mean that every engineering program in the nation is accredited? The reality is no, they're not. We are one of the elite that are accredited by that program. That means qualifies you to sit for engineering and training after your graduation, and after 5 years of professional experience, you get certified and you become a professional licensed engineer. Part of that accreditation, we call it assessment. So we assess our educational experience through setting some goals. And the goals, we call them student outcome, SO, student outcome. If you look at the accreditation body, which is called ABET, Accreditation Board of Engineering and Technology. It's a national board, and part of that is we have to identify student learning, we call them student outcome, and then we will measure that to see if you actually learned it. So in this course, what we are doing is we are identifying various elements of a mathematical or statistical model. We have an A through K, A, B, C, D, E, F, G, H, I, J, K. This is A. Under that, we can determine the values of a specific components of a mathematical and statistical model. And then these are the other 5 learnings objectives or student outcomes in this course. At the end of this course, by giving different projects to you and then measuring it, we would know if we are doing a good job, which means that you really need to participate. Why do we do this? Because once I assess how I've done or how we have done, we can go back and basically correct our mistakes, make it even better. And this part of that, we call it a closed loop. We go back all the time and we make it better. So far, so good? All right. Everybody's hungry, right? Noon? All right. So what tools do we use like any other course? Computer, PC, or laptop. I'm always expected to ask, how many people here have access to computer? Okay, let me ask you this. How many people do not have access to computer? Good. So everybody has access to computer. All types, PC or Mac doesn't make any difference. MATLAB. It's a mathematical software that will assist you not only in this course, but 4 years of your education. And not only that, it's going to be really helpful for you later on. And the expert in that is Dr. Bai, who's sitting back there. He's much, much smarter than me. So believe me, you want him to teach you on that course. So he will really take care of you on that. We also have Blackboard. As I said, Blackboard is a software that university provides you. Many of you actually might have had it even in your high school. This is our only mode of communication. Do you understand what that means? That means that I'm not going to call you. I'm not going to expect you to call me, email. Everything is done through that. That means you need to go there. You will find the PDFs of our classroom notes. What I present for you here is going to be available for you, so you don't really need to copy everything that I say or put on the board. everything is available to you. What I need you to do here is pay full attention and then ask very difficult questions from me and your other instructors, and make sure that they get really embarrassed and they can't answer you that question and you feel that, this guy knows nothing. All right, so let's see, this is a challenge for you to really test us on our knowledge. Blackboard, our only mode of communication. Many labs. How many labs do we have, John? 8. 8 labs for you. The objective of lab is really not to make your life more difficult. The objective of the lab is really to go over what you have learned in the classroom. So we try to really go over what you have done through an experiment that is physical, is tangible, you can see it. What I learned might be mathematics, but it has an engineering application. How many math labs do we have? 4. So between 8 and 4, about 12 labs. That's quite impressive. And recitations. We have 3 sessions of recitations. It's on Tuesday, Wednesday, and Thursday. We just found out that our TA is not available on Wednesday, so we might be forced to change it a little time. But each of you have already been assigned. How many of you know when your recitation time is? Good. That means you've gone there. If you have any problems with that, let us know. We put you in another session and so forth. But it is important that you attend at least one recitation. What do we do in that recitation? Your graduate TA is going to go over the homework questions for you from the previous week. He's also the undergraduate TAs in that recitation that is going to, they're going to go around and help you out. And if that's not enough, we are going to record that recitation, one of them, and put it on Blackboard for you. Yes?
When will the labs be?
Labs, we have set it up for Fridays. Fridays are going to be labs. So we have lectures on Monday and Wednesday. And then on Fridays, you do have labs. Now, we have 12, we have 15 weeks. So what happens in between? For example, this week, you can't have a lab, right? Do they have a lab this week? No. So what do? This Friday, we're going to introduce you to all the people in the labs. Other instructors are going to explain to you what's going to happen in the lab. And then hopefully the following week, we're going to have. The following week, actually, we're not going to have another lab because it's a labor weekend. So Monday, there will not be any sessions. So our lectures are going for next week is going to be Wednesday and Friday. So the lab starts in the 3rd week, right? So how do we evaluate your learning? 1, of course, you need to attend lectures, labs, and recitations. So what I need to do now is I have a list here of you guys. I want you to basically mark up your name so we know that you attended the lecture. 2, by the lab works, the labs that you basically conduct and submit. The homeworks. Your homework has already been assigned. If you go onto the Blackboard, you will see that every week we have an assignment. We have exams. And through that, we basically measure your performance. If that's not enough, I don't know what else. So many things. There are so many ways that you can basically find out where you are. And of course, I want every single one of you to get 100% and all get an A from us. So far, any questions? The syllabus is in Blackboard. How many of you have seen that syllabus? Any questions on that? We have really spelled it out for you. Everything is spelled out. If there is any problem, just email me. I will promise you I will immediately respond to your emails. So the question is, why is mathematics important? Why is mathematics important? Let's get some answers here. Come on. Speak up. Yes. Okay, that's very good. That's a very philosophical answer. All right. Anything else? Come on. How do we know? Yeah, go ahead. Give me examples. Let's see that you woke up this morning. How many of you use math? Raise your hand. I bet you all of you used it. All of you. You may not have realized it, but you have. Whether it goes to the budget and getting your train ticket, ordering something for food, walking, using your iPhones or other smartphones that you have used it, but you haven't realized it. So what we do, that basically in all aspects of your lives, math is applied. In engineering, in medicine. Do we use math in medicine? That's crazy. Right? Banking or finance, business. Does that make sense? Construction. Anything else? So can you ever get away from math? So the best thing is to learn it, right? How many of you feel confident that you have enough math background? And don't be shy, because I know you've all done very well, because you are the best of the best in this university. You already got your SATs, and you already got your high school diplomas, and you've been great at school, and of course, so forth. But how many of you really feel confident that you have the math background necessary for an engineering degree? None? That's impressive. No, this is very important. My wife asked me a question, and when I answered, and she said, you engineers really make me sick, because you never give me an answer, a definite answer. You always throw in a possibility of failure. There's always a possibility that you may not be able to deliver on that promise. And this is a true nature of engineering. Do we have 100% efficiency? Do we have 100% efficiency in engineering? Because because any physical system is prone to failure. If we can discover 100% efficient engineering of physical system, boy, are we not billionaires, trillionaires, It's unbelievable. So efficiency is very important. So, the answer you gave me is a typical. I'm glad. Because there got to be that degree of ambiguity in your mind that maybe I don't have what it takes. So what we want to make sure is, yes, you do have what it takes, but you have to really discover it. And that's what we're going to do in this course. So, in engineering, use it in basic sciences such as physics, chemistry, biology. How many of you had physics in high school? Good. Most of you. Use in every field of engineering. So it's not like those of you who are in bioengineering say, I don't need math. No, you do. Chemistry, yes, you do. Anything. Biology? Biology, what has it got to do with math? Yes, of course you do. The whole concept of cell biology is based on mathematical principles. So you do all, need all of that. But math basically allows us to exercise concepts prior to implementation. Does that make sense to you? Can somebody explain that to me? Yes.
Like you deal with the theoreticals, like if you want to launch a rocket or something, you calculate how fast it will go and stuff like that.
Excellent. Excellent. You know how many times we test these ideas theoretically on the computer before we sacrifice people's lives in all aspects. So this is where the tool is, the mathematical tool. Engineering plus math is everything. Do you agree? What about this? So you understand. All right? So, how do we evaluate your learning? Attendance, lab work, homework, exams, all of the above. Why did I put that question up there? Because part of your course, you're also going to be required to buy a clicker. All right? You're going to get a clicker. And we're not going to exercise it this week. You also need these clickers for your physics courses, for some of, I guess, liberal arts, right? So clicker will be part of you. What does a clicker do? Clicker does an instantaneous learning, I guess, measurement. So when I put a question up there, I ask you to click your answers immediately. So in my lecture, you're going to get these kind of questions popping up. You're not going to get a grade for it. But I want to know where you stand. You don't have the clicker right now, but you're going to have it next week, hopefully. And by doing that, you're anonymously, immediately, you're showing me how many of you have gotten the right answer. So, looking at this, what's the right answer? M? Did I hear M? E, right? Easy. So you're going to get these questions every now and then. You don't know when it's coming. And then, we'll find out. Where are we in terms of time? 12:30. All right. I guess I can start the lecture, John. So you guys, if you want to leave, that's fine. Right? Thank you. All right. So, yeah, you guys can go. I need my students here. So, straight lines.
I'm making a straight line for my book bag.
Thanks, John.
Thank you.
Thank you. The first chapter of your book is called Straight Lines in Engineering. For example, how long does it take for a car to come to a complete stop? Right? A very simple question. Do we use that in our daily lives? We do. And why is it important to know that? Right? How do we measure it? When you're driving a car, you want to find out if you use your brake, how long does it take for your car to come to a stop? Could be hitting that stop sign or hitting somebody, falling off a cliff. These are all applications of a straight line. How many of you have had algebra? Good. How many of you have found algebra boring? 1, 2, 3. Good. 4. Right. So we're going to find out why algebra was important to you. So sometimes you will see this that I show you, that the examples that I give you are going to be in courses that you will take in the College of Engineering. How many mechanical engineers here? Bioengineers? Electrical engineers? General engineering? Undecided? All of you going to have dynamics. So the examples that I give you is this. How many of you have seen this? Can somebody explain to me what that is? Yes?
That will give you your velocity based off the initial and multiplying the time by the acceleration.
Right. So if a car is moving, and you want to bring that car to a stop, the car has a velocity. What is the difference between velocity and speed? Yes.
Velocity has a direction.
Right, exactly. Or in the lamest term, it is a vector, right? A vector has a direction and a magnitude. Speed is simply, so like in this equation, basically, v of t, what does that mean? Yes,
Velocity with respect to time.
right. So velocity is a function of time, You will see that very often. A function of time. What does that mean? At different times, different velocity. So if we are looking at the velocity of that car hitting that pole, what do you want to see before that accident happens? Yes. Exactly. If velocity is 0, that means that car is stopping, right? So you want to find out in that basic equation, how long does it take for that car to come to a complete stop, which means that the velocity should become 0. So in this case, we call V naught as an initial velocity. What is in the bracket? Yes. Unit of velocity, which is meter per second. So when you're driving, how many of you drive cars? Right. So when you're looking at your panel, do you see the velocity as meter per second? What do you see it as? Mile per hour, right? So, well, we don't have mile per hour here. What have we done? Yes.
Gonna convert units.
Right. Converted the units. One thing which is very important in engineering is the unit system. So, of course, all of you must be now familiar with the metric system. So, anybody from Canada here? Okay, from other international countries? Right. So, you'll see that in most of the countries, there are kilometers per hour, right? kmh, or in Canada. Here we call it, mile per hour, MPA. So, if I want to convert mile per hour into meter per second, what should I do? How many meters is a mile? Don't know? 1,620, yeah. And then how many seconds in an hour? 60 seconds? 3,600, right? 60 minutes times 60 seconds is 3,600 seconds. All you have to do is just convert it. So the initial velocity, it is possible that you start from 0 speed. So it is possible that initial velocity would be 0. But when you're talking about a car that is moving, coming to a stop, there's a time that it starts, there's a time that it ends. How many of you have received speeding tickets? Don't be shy. These radar guns, that's what they do. They basically measure you at 2 different times, and then they measure you for your speed, and they can detect how fast you're going, and therefore they can find out what the speed is. And this is again another application that we have. So acceleration. What is acceleration? Yes. Right, that's a unit, right? But how do we define acceleration? Yes.
Like how the speed is increasing.
Right, good. What else?
The rate of change.
Rate of change of velocity, exactly. All of these is correct. The rate of change of velocity, how fast your speed change. So, if the car is coming to a stop, do we still call it acceleration? What do we call it? Deacceleration? Do we have such a word? we have a deceleration. Acceleration, deceleration. So, or we can simply say a positive acceleration and a negative acceleration. Because if it's a positive acceleration, your speed is in fact is increasing. All right? So, and the whole objective, of course, is to determine the initial velocity v naught and acceleration a if the velocity is known at the following two. So if a problem is given to us and we want to know how fast this car will come to a stop, what we want to find out is the time, and of course we want to find out the acceleration in that equation over there. So if I'm looking at a nice car like this with a velocity of a function of time, then if we basically pick 2 points in time and measure the velocity, very much like that cop that gave you a ticket, basically pointed the laser at you, and the laser basically went for a duration, found out what your velocity was, found out the difference between the two, and then gave you the ticket based on whatever was calculated. So here we are saying that at t.75 second, the car speed is 35 meter per second, and at 1.25 second is 2.4. Is this car speeding away, or is it coming to a stop? Right. Has it stopped? No. So what we are basically doing is we are finding at 2 points and measuring the velocity of that car. Now what we want to find out is how long will this car come to a stop? Right? So going back to the formula that we have, V was V naught plus AT, very much like in the form of Y is equal to mx plus b. Have you seen that formula before? How many of you have seen this? What is that? What is it? What is the equation of? Is that an equation of a circle? It's a linear equation, right? V is equal to AT plus V naught. Remember that? Which is very much like Y is equal to mx plus b. In this case, V is equal to Y and M is equal to A. So, if I'm looking at that equation that we had, which was V is equal to AT plus V naught, what would be the slope of that equation be? Right here. Equation of a line. How do we measure the slope? Let's see if we have a pen here. Hopefully this can be erased. Okay. V time. 2 points. 2 points. We have a V naught here. And of course, what we want to find out is that slope. How fast is coming to a stop. When this thing is hitting that axis, that's when the velocity becomes 0. Very much like Y is equal to mx plus b. So far, so good? All right. So looking at that, how do we measure it? How do we measure the slope? By picking up 2 points. Does it really matter which 2 points do I pick up? No, because as long as we are consistent, that when I'm picking up the y-axis of my point 2, I also find out the corresponding x-axis, x values of that. In this case, 2 velocities at point 2 and point 1, and divided by the corresponding time. In this case, the y2 or the velocity 2 is 2.4 minus 35 divided by 1.25 minus 0.75. Now, how did I calculate that value? What was my tool in order to find that acceleration? What tool did I use? A calculator, right? Of course, if you're very smart and you can do it in your, brain, otherwise you use a calculator. 65.2 meter per second. Is this car coming to a stop? Yes. Why? Because it is a negative, come on, speak up. Negative acceleration. Right? Negative acceleration. So naturally the car is decelerating. So the intercept is V naught. What is an intercept? Yes.
The point with the line crosses the y-axis.
Exactly. Isn't that great to feel smart? That we know all of these answers? Well, I'll talk to you in a couple of weeks and then we'll find out. Right? So we want to find out the V naught determined using the slope-intercept form and either data point. It doesn't really matter which of these data points that we have. So now we have found A, and I can put it in that equation, which was V is equal to AT plus V naught. We've already found A. So all we now find is V naught. We don't know what V naught is. I can pick any of these 2 points and put it in there and find out the answer. So the equation of a line, mx plus b, this is the equation that is now turned into velocity. Therefore, if I put p, 0.1, the 0.1, the value of time was 0.75 seconds, and the velocity was 35. I put it in that equation. Can somebody tell me what the value of V naught is? Pull out your calculators, smartphones. Let's see if we can get the right answer. Do we have the answer? Come on, speak up. Come on. 83.9. Does everyone agree? What's the value of that? What's the dimension? Meter per second. Why? Right. 83.9. So what does that mean? 83.9 was V naught. What does that mean? Yes. The velocity that started at, the point of intercept. Do we put 0.2? Do we get the same number? Can somebody do this? Do we get the same number? I don't want to bother you. The answer is yes. We do the same number. So it really doesn't matter which point you're in. So we started with a linear equation, which is in algebra, equation of a line, but now it is applied in dynamics. As simple as that. An algebraic equation that you are going to use in one of your engineering courses. When do they take their dynamics course, Sean? Sophomore year? Sophomore year. In sophomore year, you're going to see that equation. And then you're going to remember, oh my God, I did this. I know the answer. And guess what? There are 450 of you that are not taking this course. I've only selected the 50 of you to basically find out. I'm going to find out how you guys are going to perform in comparison to others. And if you do well, then the next batch is going to take it. So try to do really well. Don't embarrass me. So when I'm looking at the total stopping time, time required to reach 0. How do we do that? How do we find the total stopping time? Do I have the equation of that line right now? Right. So what is it? Is V is equal to acceleration, what was it? What was it? Right, times t plus, right? So now I wanted to find out how long does it take for this car to come to a stop. What should I do? Yes. That's right. So if I put that equal to 0, I should be able to get the time, right? Let's see who can give me the quickest answer to this. Whoever is the last going to buy us all lunch. How about that? Hurry up. Yes. 18.7? 18.7 second? Yes. 1.286. Which one? Do you think 18 seconds or 1.2? 1.29 seconds, which means that this car is going to take about 1.3 seconds to come to a stop. If that pole was only 1 second away, what would have happened? Exactly. This is what we do crash analysis. This is how important it is, those hundredths of seconds that you calculate in a moving objects like that. Many, many applications. It's not only that, there are other critical issues. So, if I'm looking at now the figure, on the x-axis we would have time, on the y-axis we would have velocity. That would be the equation of your line, which is simply this. So where it is crossing the v-axis, what is the value of that? What do you think that is? And on this axis, what is the value of t? What was it? There you are. Okay. Let's see, what time do we have? 9 minutes. Okay. Let's see if we can do the same thing in a circuit. So now we did the dynamics part. We're going to do it in circuits. Circuits is another course that you will take. I guess everybody will take it. It is taught by electrical engineering. What we have simply here is a circuit representing a voltage source, a resistance, and an unknown voltage. Have you ever seen such a diagram? How many of you? How many of you have heard of Kirchhoff's voltage law? Good. So what this means is that the voltage rise, the sum of voltage rises is equal to the sum of voltage drops. When we are saying it is rising, that means the voltage is increasing. From this point to that point, when it goes from negative to positive, it's increasing. On the other side, it is decreasing. What is the resistance? Why do we call it resistance? Do you know what a resistance is? Yes.
Like limit the amount of resistance going through.
Right, so it resists the current, right? Resists the current. What happens in a resistance if it resists the current? Yes,
Prevents power surge.
right? What happens to it, to that unit? What happens to it?
It's hot.
It gets hot. I tell you something. Let's say that you want to push this disk over there, and you keep pressing and pressing. What is happening inside your body? Yeah, what happens? You're getting, exactly, you're getting hotter and hotter. That's it. You're basically converting it into some form of energy, and that is what happened. Obviously, Dr. Helferty back there is kind of looking funny at me, which means that he wants to get ready for his class. We have about 6 minutes. I'm going to leave you with this to remember. We're going to pick it up next time. Remember, access Blackboard. Our mode of communication is by Blackboard. There's still about 10 or 12 of you that have not accessed it. I want you to go there, find out what your homework is. I have spelled out everything that you need to do. You need to study. What chapters? This book is full of examples. Okay, yes?
How would you get on Blackboard? Like, what's the link for it?
Blackboard.temple.edu. Yeah, you put your username and password and you're in. Yes.
What's the link for the downloadable book?
Download.
It's available
It's online.
in the bookstore.
No, but downloadable book.
Get the Blackboard, you can go to TU Portal also, and at the top left, you'll see Blackboard. Just click on it.
Blackboard.temple.edu. So I don't have the answer, I guess. All right.
You're done at 12:50. Oh,
Good?
you said that you had 10 more minutes. I'm like, oh. Whatever. Good.
Well, this not much time,